Welcome to Spotlight Advanced. I'm Roger Basick.
And I'm Katy Blake. Spotlight uses a special English method of broadcasting. It is easier for people to understand no matter where in the world they live.
A group of hamsters run around behind bars. These small animals are a lot like mice. They are usually very friendly. Many can live together without a problem. They like being around humans, so people often keep them as pets.
Suddenly, one hamster starts to attack another. It comes up from behind and holds the other down. The hamsters begin biting each other. Soon, all of the hamsters are fighting. It is as if they have all gone to war. But this war has no sides. Each hamster is out for himself.
This is not how normal hamsters behave. But these are not normal hamsters. These hamsters have had their genes changed by scientists. The scientists used a technology called CRISPR to change their DNA. The scientists believed their work would make the hamsters less likely to fight. But their experiment did not go as planned. Today's spotlight is on the good and bad possibilities of CRISPR.
CRISPR is a gene-correcting technology. It lets scientists target a part of an organism's DNA. Then they can remove or change it. Genes and DNA are very important parts of all living things. They determine how an animal or plant develops. In people, genes are just as important. Your genes are the reason your hair is a particular colour. They are why you are as tall as you are.
But some genes are harmful. Sometimes blindness is genetic, as are some cancers. Diseases like cystic fibrosis and sickle cell disease are also genetic. If a person has the genes for one of these diseases, she will likely develop the disease. And if she has the genes for the disease, there is no cure.
But CRISPR could change that. It is still a very new technology, but it may be able to change the genes of people who already have these illnesses. It could heal what people did not think could be healed. Samarth Kulkarni is the Chief Business Officer of CRISPR Therapeutics. He spoke to McKinsey Management News.
When it comes to medical uses, CRISPR could affect many treatment areas. It could help with hundreds of diseases, both rare and common. It lets us target the hidden cause of a disease. We might even cure someone by changing their DNA. Some long-term uses are extremely exciting.
But changing a person's genes is very difficult. H. Elliot Albers is a neuroscientist at Georgia State University. He is the one who changed the hamster's DNA. Before the animal was born, he used CRISPR to take out a chemical in the hamster's brain. It is called vasopressin. Hamsters make vasopressin naturally. But these changed hamsters could not create it. Albers also took out vasopressin receptors. These special areas of the brains of the hamsters uses the chemical. Even if the hamsters could create vasopressin, they could not use it. Injecting more vasopressin into the hamsters makes them more likely to fight. So Albers believed taking it out would make them peaceful. But instead, it did the opposite. And Dr. Albers does not know why. He spoke to Georgia State University News.
We do not understand this system as well as we thought we did. The strange findings tell us we need to start thinking differently. We need to think about the actions of these receptors across the whole brain. We cannot think about only one part.
Dr. Alber's study may not seem like it relates to humans, but the study shows something very important about genes. DNA is very complex. Human brains are very complex too. There is a lot that even great scientists do not know. Using CRISPR may have effects we do not yet understand. Making angry hamsters is one thing, but a similar mistake in a person would be terrible.
Still, CRISPR is a new technology. Scientists may have a lot to learn about how changing DNA will affect people. But in the future, these changes will be better understood. Dr. Alber's study is also very different than most CRISPR treatments. He changed the genes of his hamsters before they were born. This had a greater impact on how they grew. It changed the animals completely. CRISPR has already helped people with genetic diseases, but these people were adults. CRISPR helped treat their problems. It did not change them altogether.
Today, even trying to change an unborn baby's genes is illegal in most countries. Dr. He Jiankui is a Chinese scientist. He is the only person to alter the genes of an unborn baby. But Dr. Jiankui was put in prison for his work. Most scientists agree that it was not ethical. And most governments agree. This kind of gene alteration could lead to developmental problems. It could even give the children a greater risk for cancer.
But Dr. Jiankui's work was dangerous. He changed a person's life without knowing what it would do. And altering genes this way could be bad for the baby's health. It could cause a condition called genetic mosaicism. Genetic mosaicism causes a person to have both normal and abnormal genetic patterns within the cells. Genetic mosaicism can lead to cancer. It also causes developmental problems. It could affect blood cells, skin cells, and reproductive cells. Dr. Jiankui was jailed for his work, and he will never be able to do this kind of work again.
Using CRISPR has some risks. A bad use of the technology could hurt patients. It could change them in ways they do not want. But this is also true of most medical treatments. Many medicines have side effects. A badly done surgery can hurt more than it can help. Despite these problems, CRISPR is an important technology. One day, doctors may be able to use CRISPR to prevent disease. This may help cure people in ways that seem impossible today. If this day does come, it is important to use it well so that all people can benefit.
Nessun Birmingham is a founding member of Intellia Therapeutics. The company develops medical treatments using CRISPR. He told McKinsey Management News,
"We need to make sure that all people around the world suffering from a genetic disease can use this technology. And we should make sure that this technology addresses today's medical needs. That should be our goal."
Would you let a doctor treat you with CRISPR today? Why or why not? We hope you can join us again for the next Spotlight programme. Goodbye.